Hi everyone. Now I'm going to explain the last part of this section, the mean value theorem. If a function is integrable on a given interval, then the mean value or the average value of this function on the interval is integral of that function on the given interval. We know how to find integral. It is definite integration from lower bound to upper bound. The interval will be written here. We take the integral of the given function on the given interval, divide by the difference of two bounds. Okay, take the integral of the given function on the given interval and divide it by difference of the intervals, b minus a. Or you can write this b minus a as multiplication in front as 1 over b minus a. It's the same. Let's take a look at the first question. Study guide 21b. Find the mean value for this function over this interval. So apply the formula 1 over b minus a. What are the bounds? 0 and a. So the bounds are upper bound a minus lower bound 0 times integral from lower bound 0 to upper bound a of f of x dx. Now I have a coefficient here. I can move it out in front. So I'm going to have 1 over a times integral from 0 to a of square root of x dx. I can rewrite square root of x as x to the half. Now a's will simplify. I will be left with this integration. So let's do this integration. Integral of x to the half is x to the 3 over 2 over 3 over 2. So when you write this in front, you're going to flip it, write it as 2 over 3. And you integrate this at each bound, a and 0. Let's put a first and then 0 for x. So it is 2 over 3 a to the power of 3 over 2 minus 0 to the power of 3 over 2. It doesn't have an effect, so it's just going to be 2 over 3. If you write this as radical, a cubed on the radical, or when you simplify it more, you can take a squared out in front. So it's gonna be 2 over 3 a root of a. Okay, it is pretty simple when you know the formula. Okay, one more question. Find the value of b, where the mean value of the function over this interval is equal to 6. This time, the mean value is given as 6. Equalize it to the formula. Formula is 1 over difference of the bounds, which are b and 1, times integral from lower bound to upper bound of this given function dx. That's it. Now, 6 is equal to 1 over b minus 1. Take the integral. Integral of 2x is 2x squared over 2, which is just x squared, plus integral of 1 is x. We are integrating this at b and 1. So let's substitute the upper bound first and the lower bound, which will be in a bracket b squared plus b minus 1 squared plus 1. Okay, 6 is equal to 1 over b minus 1. We are going to have b squared plus b minus 1, 1, 2. I don't want fraction here. I don't want a denominator. So I want to remove it by cross multiplication. Multiply 6 by b minus 1. So 6b minus 6 is b squared plus b minus 2. Since it's a quadratic equation, let's bring everything to one side of equation. Get 0 on the other side. B squared. 6b to the other side, it's gonna make negative 5b. Negative 6 to the other side will make positive 6 minus 2 positive 4, which is 0. Now factorize bb 4, negative 4, negative 1. Negative 4 times negative 1 makes 4. Negative 4 plus negative 1 also makes negative 5. So that's correct factorization. It's going to be b minus 4. B minus 1 is equal to 0. So our b is 4 or 1. So are they both true? If b is 1, what happens? If b is 1, our bounds will be the same. If upper and lower bounds are same, what is the result? Result is 0. So b cannot be 1. Our bounds cannot be same. So the answer must be just 4. Option B. Okay. Now, there is another type of question that is in our book, exercise 33, and this type came a lot in Wazari. Let's take a look at this question and see how to solve. We are given a figure. We are asked to evaluate integral from 1 to 7. We are not given a function. Instead, we are given a figure. So for these kind of questions, all we need to do is finding the area under the given figure, because integral means area. So we're gonna break this figure, this piece, break this graph into pieces. I see a triangle here. I can make a triangle. I can make another triangle, and for the leftovers, I can make a rectangle. I have a rectangle, two triangles, and I know how to find the area of rectangle and the triangles. So this is not a hard question for me. It is so easy. So now, what is the area of A1? A1. It is rectangle. Area of rectangle is base times height. So what is your base? From 1 to 7, you have 6 units. Multiplied by height, you have just 1. Plus, what is the area of triangle? Let's start with the first triangle. Base times height times 1 over 2. 1 over 2 times base times height. Our base is 1 to 2, 1, times height is 1 to 3, 2. Plus second triangle, 1 over 2 times our base, 2 to 4, 2, times height, 1 to 2, 1, which is equal to 6. 2's cancel each other, plus 1, plus 2's cancel each other, 1, 1, 1, 2, 6 makes 8. So the answer of the first part is 8. Second part is asking about the mean value. So what was the mean value? Mean value was the integral from given bound, lower bound to upper bound of the function divided by difference of the bounds. I already found this integral in the previous part as area as 8. So I have 8 at the top, 7 minus 1, 6 at the bottom. So simplify 6 over 8. If you divide both top and bottom by 2, you're gonna get 4 over 3. Alright. Part C. Repeat questions part A and B, assuming that the graph is shifted 2 units up. If you shift your graph 2 units up, then you don't change the triangles. Triangles will not change. What changes is only the rectangle. The rectangle was like that. When you shift it 2 units up, it's going to be wider. So the only area of rectangle changes. Area of rectangle is base, which is 6 times its height changes. It was 1 at first, now it became 3 because you moved your graph 2 units up. So it's now 6 times 3. Plus, the areas of triangles are same as in the first part, which are 1 and 1. So 6 times 3, 18. 18 plus 2, 20. Okay, this is the area under this figure, the new area under the new figure. Part B was asking about mean value. So the mean value is the integral divided by the bounds. The bounds are also the same, 7 minus 1, So 20 minus 6. When you divide top and bottom by 2, it's going to be 10 over 3. All right. So as you can see, there are many ministry questions about this figure type. Okay, now I'm going to explain one last question about this section, not about mean value, about this section. Exercise 34 and exercise 38 are similar, so I'm just going to explain one of them. There's a similar ministry exam question too, so I'm just going to solve this exercise question. What is the question? G is a function defined by g of x equals integral from 0 to x of f of t dt. We solved questions about this in the previous lesson, if you can remember. We talked about a property about this. We said that if we have g equals an integral, then it means inside the integral we have derivative of this outside function, right? So if I have g outside, inside the integral I have g prime. So this is pretty important to make this connection to solve this question. Otherwise, we can just solve the first part, we cannot solve the other parts. Okay, this is important, keep in mind. Now we are given f function, the graph of f, but questions are about g. So how are you going to make a connection? We know that g is this, f is g prime. Now let's find g of 0. We are going to use integration, of course. Just substitute the given values for x in the given function. G of 0 is equal to integral from 0 to x, which became 0, of let's say f of x dx. Then the bounds are same, so we can directly say result is 0. What about for 2? It's from 0 to 2 now. Since the function is not given and the graph is given, as in the previous question, in order to find the integral of a function, if the graph is given, then we are going to apply area. So let's find area from 0 to 2. From 0 to 2, I see a triangle, so I will find area of triangle. But since this part is below x-axis, it's going to be negative. So negative area is 1 over 2 times base times height. Our base is 2. Height is how many units down? 4. Those cancel each other. Result is negative 4. Okay. Another one, g of 4. It's from 0 to 4 of f of x dx. 0 to 4. So this area is same as this one. If this one is negative 4, this is also negative 4, right? They are same. So I can directly say negative 8 without solving because I already knew the previous one. G of 6, the next one, means integral from 0 to 6. So I can write this by using a property. I can break it up into pieces. I can write integral from 0 to 4 for f of x dx plus from 4 to 6 f of x dx. I already found integral from 0 to 4 in the previous question as negative 8. What I need for this question is finding integral from 4 to 6. From 4 to 6, this one, I have a trapezoid. If you remember the formula of trapezoid, you can directly apply this formula and find the area under this figure. If you don't remember it, you can still break this trapezoid into 2 pieces. Like you can get a triangle here, let's say area 1, and a rectangle here, area 2. So What is the area of the triangle one and this triangle and this rectangle? Let's write this as negative 8 first, plus evaluate the area of triangle and rectangle one by one. Area of triangle here is 1 over 2 times base times, which is 1, 4 to 5 we have 1, times height, we have 4 units up, plus base times height is the area of um, rectangle, so which is 1 by 4. So here I have 4 and 2 cancels, we have 2, here 4, we totally have 6. This part is 6. So negative 8 plus 6 makes negative 2. Okay, this is the answer to question answer to this question for g of 6. So I get this upper part, area of this upper part, as 6, right? This is 6. Now, what is next? The next one is asking about g of 8. As I did in the previous question, I can break this up into pieces and write this as integral from 0 to 6 plus 6 to 8. I already found this in the previous question, 0 to 6, as what? As negative 2. Now I'm going to find integral from 6 to 8. Integral from 6 to 8 means the area from 6 to 8. What is the area from 6 to 8? I already found this upper part in the previous part as 6. Since they're identical, okay, this is half of the entire figure in the upper side of the x-axis, then this part is also 6. So without evaluating it one more time, I can immediately write 6 here. So what do I have? Negative 2 plus 6 is equal to 4. Okay. So 2024, we have a similar ministry exam question. This question has a second part. It's asking about the intervals where g is increasing and decreasing. So as I did in chapter 4, section 1, I will make a table in order to figure out increasing and decreasing intervals for function g. I need to know where derivative of this function is positive or negative. Remember from chapter 4 section 1, if derivative is positive, function is increasing, negative, function is decreasing. In the beginning of the question, I mentioned that in an integral, if we have g outside, inside the integral, we have its derivative. So we're going to use that idea. This function represents g prime, actually. So we can identify sign of g prime from the function. Let's take a look at the, from the graph, sorry. Let's take a look at the graph. Go back to the graph and identify the signs. Our graph is below x-axis from 0 to 4, and after 4 until 8 it is above x-axis. So when we identify the sign of g prime, we can say 0 to 4 negative, 4 to 8 positive. 0 to 4 negative, 4 to 8 positive. So if function's derivative is negative, then if slope is negative, then function is decreasing. If slope positive, then function is increasing. So our increasing interval is from 4 to 8, while our decreasing interval is from 0 to 4. So this is a nice question. This is a combination of chapter 4 section 1 and chapter 5 section 2. So we are done with this section.